Scientists discover the anxiety gene in the brain and a natural way to turn it off. They see huge potential for it to lead to new anti-anxiety medications. The discovery of an anxiety gene, they call it, in a natural way to turn it off in the brains of mice could lead to new treatments for anxiety disorders, which are the most common type of mental illness in the world. The challenge, while anyone can experience worry or dread, people with anxiety disorders experience those feelings pervasively and often for no identifiable reason. Medications can relieve the symptoms of anxiety, but because we don't really know what is going on in the brains of people with anxiety, finding the right drug or combination of drugs can be a time-consuming process of trial and error. The suppression of the gene appeared to provide stress relief and reduce anxiety-related behavior, in the mice, of course. The anxiety gene, to understand what's happening in the brain to cause anxiety, a UK-led team of researchers restrained mice for 6 hours to induce a stress response and then analyzed the rodent's brain on a molecular level. This led to the discovery of increased levels of 5 microRNAs, miRNAs, small molecules that help determine which genes in a cell are expressed and which are not in the amygdala, the brain region implicated in anxiety. When the researchers took a closer look at the miRNA, the microRNAs that reached the highest levels, MIR483-5P, they saw that it suppressed the expression of the PGAP2 gene, and that this suppression appeared to provide stress relief and reduce anxiety-related behavior. miRNAs are strategically poised to control complex neuropsychiatric conditions such as anxiety, said co-lead author Valentina Mosienko. She said, but the molecular and cellular mechanisms they use to regulate stress resilience and susceptibility were until now largely unknown. The MIR483-5P PGAP2 pathway offers a huge potential for the development of anti-anxiety therapies, Valentina Mosienko said. And looking ahead, if further research validates the finding in human brains, the discovery of this anxiety gene and a natural way to put the brakes on it could serve as a blueprint for the treatments to help people with anxiety disorders. The MIR483-5P PGAP2 pathway we identified in this study, activation of which experts anxiety-reduce effects exerts the anxiety-reduce effects, offer a huge potential for the development of anti-anxiety therapies for complex psychiatric conditions in humans, said Mosienko. And this is on Collective Spark by Christine Hoser of Freethink. Please leave your comments and thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.